Okay, students, in orientation session, we discussed that first of all, our important section is related to journal physics. So there are many chapters in journal physics related to forces, related to motion, related to mass, volume, density. So we are starting with our first chapter. Because there is no sequence, you may choose any chapter to start first and then go on with your sequence. There is no hard and fast rule to continue with specific chapters. So first of all, we start with some basics chapters, the easy chapter that will help you to boost your confidence for the physical quantities and other concepts. So first of all, we are starting with mass, weight, and density, right? Because motion chapter is very much lengthy and there are many concepts related to that. So first of all, we start with some basic chapter, because these chapters, mass, weight, density, pressure, these chapters are very much small and there are little concepts in that. So first we done with these chapter, then we will continue with the motion chapter and forces chapter. Okay, so in chapter mass, weight, and density, let's start with the first concept. And the first concept is that you need to know about the difference between mass and weight, because mostly we consider that both mass and weight both are the same quantities. हम daily life में normally क्या करते हैं कि हम दोनों को same quantities consider कर लेते हैं, mass को भी weight को भी, because in our daily life we are not going to specify any quantity or any SI unit, or we are not going to solve any physics problem in our daily life like in our physics syllabus. So that's why we used to name same words like mass, weight, or for any object. So first of all, you need to know that there is a clear difference between both quantities, mass and weight. Both are not same quantities, both are different quantity. So first of all, if we talk about the difference between mass and weight, so we need to know about the difference between mass and weight first. So first of all, if we want to define that what is mass, so the basic concept of mass is, any idea? So if we want to define the mass, so mass can be defined as quantity of a matter in a body. So this is very simple definition. और अगर आप इसको simple consider करते हो तो let's suppose अगर हम दो boxes consider करें, let's suppose if there are two boxes, one box is filled up with marble and second one is filled up with stones. So मटेरियल डिफरेंट है दोनों में, ठीक है, दोनों में आपको पता है कि सॉलिड मटेरियल है, दोनों का स्ट्रक्चर डिफरेंट है, दोनों की फॉर्मेशन डिफरेंट है, बट आपने यहाँ पर ये कंसिडर करना है कि हम उसके सिर्फ मास की बात कर रहे हैं. तो बेसिकली उन बॉक्सेस को कंसिडर करने का रीजन ये कि हमने जो उसमें मटेरियल फिल किया है, तो उन मटेरियल की जो क्वांटिटी होगी वो आपको बताएगा कि आपके पास मास या उस ऑब्जेक्ट के लिए या उस बॉडी के लिए मास किस चीज को डिफाइन कर रहा है. तो दैट क्वांटिटी ऑफ अ मैटर इन अ बॉडी, बिकॉज मैटर के बारे में आपको पता है, मैटर इज एनीथिंग विच हैव मास एंड ऑक्यूपाई स्पेस. तो जिसका मास हो, जो स्पेस ऑक्यूपाई करे, वो हमारे पास मैटर होता है. ये सारी बेसिक डेफिनेशंस हैं जो हम साइंसेस में करते आए हैं, ठीक है. अच्छा, नॉर्मली ये होगा कि आपके पास जो डेफिनेशंस होंगी और जो कॉन्सेप्ट्स आपके पास एग्जाम में पूछे जाएंगे, तो वो मैं सारे यहाँ पर जो है वो नोट डाउन कर दूंगा. ठीक है, आप अपने साथ नोटबुक रखना, जब कोई क्वेश्चन सॉल्व करना हो या कोई क्वेश्चन पूछना हो, सो यू नीड टू राइट इन योर नोटबुक, देन यू आस्क व्हेन टॉपिक इज डन. So I will also share the PDF file of this complete notes after the class, after each class. So you may note down the remaining topic or the remaining concepts after the class. Okay. So this is the basic definition of mass. And if we compare it with the weight, right? So the second quantity is weight. Now let's see what is the difference between mass and weight. So let's suppose we know that every object has some mass. Let's suppose if we are talking about those two boxes, one containing marble, second one is containing stone. So basically, we know that on our Earth there is a gravitational pull, right, or a gravitational force, because every planet has its own gravitational strength or gravitational force, which attract any other body which is on the planet or on the surface of the planet. ठीक है, हर प्लेनेट की अपनी एक ग्रेविटेशनल फोर्स होगी जो उसे डाउनवर्ड पुल करती है। ठीक है, यहाँ तक कोई कंफ्यूजन? अभी अच्छा, ये फोर्सेस वगैरह में कंफ्यूज नहीं होना कि फोर्सेस को कैसे डिफाइन करेंगे, ये सब जैसे वो टॉपिक आएगा हमारे पास हम उसको भी डिस्कस करेंगे। ठीक है, so if we want to define the weight, so in simple words we can define weight as weight is a force ठीक है, तो बॉडी में क्या होता है, नॉर्मली जब भी हम प्लैनेट की बात करते हैं तो एवरी प्लैनेट अप्लाइज फोर्स ऑफ अट्रैक्शन ऑन एनी अदर ऑब्जेक्ट एंड दैट ऑब्जेक्ट इज गोइंग टू अट्रैक्ट टुवर्ड्स द surface or towards the center of that planet, right? So that's why we say that that weight is a force which is acting downward or towards the center of the surface or towards the center of the planet or anything, right? और मास जो है वो सिंपल क्वांटिटी ऑफ अ मैटर इन अ बॉडी। ठीक है, और सेकंड डिफरेंस, अच्छा सेकंड डिफरेंस के लिए आपको याद होगा हमने दो क्वांटिटीज डिस्कस की थी। द फर्स्ट वन इज स्केलर क्वांटिटी एंड द सेकंड वन इज वेक्टर क्वांटिटी। सो व्हाट इज द डिफरेंस बिटवीन स्केलर एंड वेक्टर क्वांटिटी?
Scalar quantity have magnitude and vector quantity have both magnitude and direction.
Yes, very good. So in scalar quantity, we know that scalar quantity consisting of the magnitude, यानी इसमें हमारे पास एक quantity होगी fix plus SI unit that is compulsory for any physical quantity. And second, if we talk about vector quantity, so in vector quantity, we know that in vector quantity, we have magnitude. It means the number or the quantity plus direction plus SI unit. Again, SI unit is always compulsory for any physical quantity. So let's suppose now if we want to categorize mass and weight into scalar and vector quantities, right? So there are basically two journal terms. First one is scalar and second one is vector. And you need to categorize mass and weight into scalar and vector. So which quantity will be scalar and which quantity will be vector? If we talk about mass, so mass will be scalar quantity or vector quantity? मास में आपको क्या डायरेक्शन रिक्वायर्ड होगी या नहीं होगी?
A vector quantity mass is.
Mass is vector quantity. Okay. And if we first let's differentiate between mass and weight. The definition written in mass is quantity of a matter in a body. It means it only concerned with the quantity of a matter. जब हम सिर्फ quantity की बात कर रहे हैं तो इसका मतलब है हम किसकी बात कर रहे हैं? Only magnitude, right? And when we are talking about the weight, मास वुड बी स्केलर, वेरी गुड। एंड जब हम बात कर रहे हैं वेट की तो वेट इज अ फोर्स एक्टिंग डाउनवर्ड, सो डाउनवर्ड इज अ स्पेसिफिक डायरेक्शन, सो इट मींस देयर विल ऑलवेज अ क्वांटिटी और अ मैग्नीट्यूड फॉर एनी फिजिकल क्वांटिटी। तो इसका मतलब है वेट के लिए हमारे पास मैग्नीट्यूड भी होगा और उसमें हमारे पास डायरेक्शन भी होगी। सो अकॉर्डिंग टू दैट मास इज अ स्केलर क्वांटिटी एंड वेट इज अ वेक्टर क्वांटिटी, राइट? एनी कंफ्यूजन?
No, sir.
Okay, now one more difference. One more difference is the difference between the symbol and difference between the SI unit, because we know that both are different quantities. So obviously both have different SI unit and different symbol. So if we talk about the symbol for the mass, so the symbol for the mass will be small m and the symbol for the weight will be equal to W, right? So this is the symbol for mass and weight. And if we talk about the SI unit, so the SI unit for the mass will be kg, kilogram is the SI unit for mass. And if we talk about the SI unit for the weight, so the SI unit for weight will be equal to, any idea? So basically weight is a force, and we know that Newton discovered, or we can say that Newton just provide us the law of motion. So that's why we consider weight, the SI unit for
Mass.
weight as Newton, capital N. So basically the
Okay.
SI unit for weight is Newton, right? Okay. And one more thing, let's suppose if we have a different unit given in our question. Let's suppose if we are talking about mass, and let's suppose in our question it is mentioned that let's suppose quantity is not mentioned in kg, quantity is mentioned in gram, right? Let's suppose it is written that in a question 100 gram, and you need to convert that 100 gram into kg, because kg is SI unit and we need to convert 100 grams into kg. So any idea that how we are going to convert grams into kg? If you remember, we discussed in our last class that if you want to convert a large unit into small unit, or a small unit into large unit, so first of all you need to identify that gram is a small unit or a large unit.
A small unit gram
Yes,
is.
gram is a small unit and kg is a large unit. So if we want to convert a small unit into large unit, so we need to divide the quantity, right? Because we know that when we are going to write a larger unit, so number will be less, right? Let's suppose if we are having a 100 rupee note, so 100 rupee is the quantity, or we can say that the magnitude of that currency or that money, right? And we are having a single note. And if we divide, or if we exchange that 100 note with 10 notes of 10 rupees, so again we are getting the same value, but the quantity will be different, right? So when we are working with the small units, so there will be a large number, but we know that the unit is small, right? And when we are working with large unit, so we know that a number will be small but quantity will be same. ठीक है? तो जब हम लार्ज यूनिट यूज करते हैं तो हमारे पास मैग्नीट्यूड लिखने में कम होता है, लेकिन उसकी वैल्यू सेम होती है। जिस तरह हम 100 रुपी नोट की बात करें, अगर एक 100 रुपी नोट हो आपके पास, ठीक है, और आप उसको जो है वो चेंज करवा के 10 10 के 10 नोट्स ले आओ, तो वो 10 नोट्स दिखने में तो ज्यादा है, लेकिन उसकी वैल्यू उस 100 के एक नोट के बराबर है। तो सेम हमारे पास स्मॉल टू लार्ज और लार्ज टू स्मॉल का कॉन्सेप्ट होता है। ठीक है, सो ऑलवेज रिमेंबर, आप किसी भी सब्जेक्ट की बात कर लो, व्हेन यू आर स्टडिंग केमिस्ट्री, बायो, फिजिक्स, मैथ्स, एनीथिंग, सो दिस इज जनरल और यूनिवर्सल रूल दैट व्हेन वी आर गोइंग टू कन्वर्ट स्मॉल यूनिट इनटू लार्ज यूनिट, सो वी नीड टू डिवाइड द क्वांटिटी, and when we are going to convert large unit into small unit, so we need to multiply the quantity. So for this question we need to convert grams into kg. So for that we know that 1 kg will be equal to 1000 gram, right? Because this is a constant value. So how we are going to convert gram into kg? We just need to divide 100 grams by 1000, because we know that we are going to convert a small unit into large unit and we need to divide the term. So that's why we simply divide 100 by 1000 and you will get the answer 0.1 kg. So in comparison, you can see that the number which is mentioned with kg is small as compared to the number which is mentioned with the gram. But we know that the value of both units are same, right? Any confusion?
No, sir.
So basically this is a general concept of unit conversion for mass. When we are having different unit and we need to convert that, so we need to memorize this rule. And we already discussed the difference between mass and weight. And there is a similarity, or we can say that there is a link between mass and weight. And what is that link? Let's suppose if we are having a quantity of mass, or let's suppose if we are having a quantity of weight, and we need to find another quantity. Let's suppose if we talk about a formula, that formula is related to mass and weight, and that formula is W equals to mg. So you know that W is the weight, right? W represents the weight of a body, M represents the mass of a body, and what is small g? What is a small g? Any idea?
Gram.
No, basically, G is a new quantity. Remember that when we are talking about the concept of weight, so the concept of weight is that every planet has gravitational pull, or gravitational force, or gravitational attraction, right? So basically, this small g represents you, or this small g gives you the concept of acceleration due to gravity, right? Acceleration due to gravity, or simple words, gravitational field strength. Let's suppose if you are on an earth surface, अगर हम एक earth surface को consider करें, and if we take the example of moon surface, तो आपको gravity कहाँ ज़्यादा feel होगी, on earth or on moon?
On Earth.
On earth.
Yes.
So basically on earth आपको gravitational field इसलिए ज़्यादा feel होगी because the gravitational field strength, or the gravitational pull of earth is stronger than moon, right? So that's why the gravitational field strength of earth is greater than gravitational strength of the moon, and this value is constant because we know that the earth remains same, right? earth में कोई change नहीं आएगा, तो earth की gravitational field strength भी कैसी रहेगी, same, राइट? आप मून पे जाओ, आप डिफरेंट प्लैनेट्स की ग्रेविटेशनल स्ट्रेंथ को कंसिडर करो, सो ईच प्लैनेट हैज इट्स ओन ग्रेविटेशनल फील्ड स्ट्रेंथ, राइट? एनी कंफ्यूजन? यहाँ तक कोई
No.
कंफ्यूजन, कोई क्वेश्चन, कोई? ओके, नाउ वन मोर डिफरेंस बिटवीन मास एंड वेट. Very important difference, because in most questions they used to ask about that specific difference, or that specific concept, and that concept is that mass remains same everywhere. Mass remains same everywhere. And what about weight? Basically, weight depends upon the value of G, right? So basically, there is very important difference between mass and weight. That is, mass remains same everywhere, and weight depends upon the value of G. So how mass remains same everywhere? In initial stage, we discussed that mass is a quantity of a matter in a body. Quantity of a matter in a body means, I just quote the example of that marble in a box. Marble in a box means, let's suppose there are 10 marbles in a box, and we are on earth surface, right? And if we take that box on moon surface, So is there any difference in the quantity or in the structure of that marble? अगर हम मार्बल को अर्थ सरफेस पे कंसिडर करते हैं, हमारे बॉक्स में 10 मार्बल्स है और उन्हें हम लेकर जाते हैं मून सरफेस पर, तो क्या दोनों सरफेस पर हमारे पास उन मार्बल में कोई चेंज आएगा? उनके स्ट्रक्चर में, उनकी क्वांटिटी में? नहीं
Yes,
आएगा।
in the moon. Yes,
यस।
in the moon, marble will be flying.
Yes, but only a difference is that marble will like a flying on the moon, but not on Earth. So it means that the structure will be same, the quantity will be same. So it means mass remains same, right? Because when we are talking about the quantity, so 10 marbles will remain same on the moon also, and the mass of those marble will also remain same because their quantities are same. But the difference is that the value of G means the gravitational field strength. So when the gravitational field strength will be different, so it means that weight will be changed according to the surface of planet, because it depends upon the value of G. So if the value of G will increase, weight will also will increase. And if the value of G will decrease, so weight will also decrease, right? Just like the example of Earth and Moon. Okay, any confusion?
No, sir.
Okay. And one more important thing, that how we measure mass and weight, because we know now we know that there is a difference between mass and weight. So it means that we have to measure both quantities with some different measuring instrument, right? So let's suppose if we want to measure the mass, so how we are going to measure mass and how we are going to measure the weight, or we can say that what are the measuring instrument for mass and weight? Any idea? So normally we measure mass using spring balance or beam balance. जब आप मार्केट जाते हो नॉर्मली, अब तो खैर सब जगह इलेक्ट्रॉनिक यूज होते हैं बैलेंस, लेकिन ओल्ड अगर आपको याद हो तो वो दोनों साइड सीसॉ टाइप बैलेंस होता है, ठीक है? तो दैट इज नोन एज स्प्रिंग बैलेंस और बीम बैलेंस। अब नॉर्मली अब तो nowadays we are using इलेक्ट्रॉनिक बैलेंस। बिल्कुल सही, आपने वेट के लिए सही लिखा, वेइंग मशीन हम यूज करते हैं। एंड फॉर and to measure the weight we use normally in laboratories or in lab we need to use a Newton meter. So basically Newton meter is something different. Let me show you that how Newton meter looks like. Because Newton meter is a different measuring device because we are not going to use in our daily life. Yes, this is Newton meter. Is it visible?
Yes, sir.
So in labs, mostly we use this Newton meter to measure the weight. As you can see that there is n, it means Newton is mentioned on the scale, right? So we can easily measure weight by using this Newton meter. There are different multiple structures, like it will be in a cylindrical form like this, or it will also available in digital form, right? Because we know that when we are talking that weight is depending upon the value of G, that is the gravitational field strength. So it means that we need to hang the object, right? Because it always acts in downward direction or in downward position. So that's why we need to hang the object by using the Newton meter or digital Newton meter or any type of Newton meter. So that will give you the value of the weight like this. An apple is hanging on Newton meter, and you can see that the value is something different, increasing from 0, right? So this is the difference between mass and weight, and the measuring instruments we are using for to measure mass and weight. So either we are using manual Newton meter or electronic Newton meter. So concept remains same, only the type of measuring instrument in different, right? Any confusion?
No, sir.
Okay, so this is very important topic, and this is, we can say that these are the whole important points or the whole notes related to mass and weight. All questions are based on these type of concepts. Let me show you the questions. So let's try to solve some question, then we will discuss some other topics, right? Okay, so screen is visible.
Yes, sir.
Okay. Okay, I will send this PDF to you also in the group, right? So day by day, you try to solve the question one by one, because all questions are from your past papers. So that will give you a clear concept of the topic, that how the questions are going to be included in your exam related to your topic, right? So starting from first question, an object has a mass of 50 kg. So what is the symbol for mass?
Kilogram.
No, no, symbol.
F50.
Uh, this is the symbol. Small m, right? Yes, m. So it means that while solving the question, just keep in your mind or just write on the paper that the symbol for this 50 kg is m. So that will give you the idea that which formula is going to be fit into this question, right? And the gravitational field strength on earth is 10 newton per kg. So what is gravitational field strength? If you remember, small g, right? So small g is the symbol for gravitational field strength, right? Any confusion? And
No.
they are talking about the Earth's surface, the gravitational field strength on a distant planet. So now we are talking about a distant planet. Like there is some other planet. So we write GE, gravitational field strength of Earth, and this is an other gravitational field which is for distant planet. So we write GED, distant planet, right? So what is the weight of the object on Earth and what is its weight on the distant planet? So basically they are asking you for two things. What is the weight of the object on Earth? And the second question is, what is its weight on the distant planet? So you need to find out two weights, right? So basically you need to find out the two quantities of weight. One is weight on Earth, WE, and second one is weight on distant planet, WD, right? So what is the formula for weight? W equals to mg, right? Any confusion?
No.
Okay, so we need to find two different weights. So we write it as We equals to mg E, and the second one is WD is equals to mg D. So why we are writing m, only m for both formula? Why we are not writing me or md? Because there is only one quantity of mass mentioned in the question. So what is the reason why we are not writing ME or MD? Why we only write M for both the formula? Any idea? If you remember,
Because there is mass is mentioned there.
yes. And we know that the mass remains same everywhere, right?
Yes.
So always remember these 2 points, that mass remains same everywhere, weight depends upon G. This is very important concept. So now just we need to solve the calculation. Mass is equals to 50 and acceleration due to gravity for Earth is 10. So 50 multiplied by 10, and same goes for the second one. 50 is the mass and the gravitational field is 4. So 200 and 5000. And what is the SI unit for weight? And what SI unit for weight is Newton, right? You may check from the notes. We already mentioned that SI unit for weight is Newton, right? So what will be the answer? It is 500 weight. Yes, it is 500 Newton. Now what is the right answer? We know that mass on Earth is 500 Newton and the mass on weight on distant planet is 200 Newton, right? So these are two values. So according to that, which option will be correct?
Uh, option A.
Option A.
Option A, I think.
This is WE
Yes.
and this is WD. WE weight on Earth and WD weight on distant planet. So weight on Earth is 500 and weight on distant is 200. Sorry, option D, because the SI unit is different. 500 Newton and 200 Newton. In option C, there is a problem in SI unit. The kg. We know that kg is the SI unit of mass, right? And the SI unit of weight is Newton. So there is a problem in SI unit, right? Any confusion?
No, sir.
Okay. So basically, this is a question that how questions are going to be include. Let's try one more question. An astronaut in an orbiting space experience a force due to gravity. This force is less when she is on Earth's surface. So basically question is an astronaut in an orbiting spacecraft experience a force due to gravity. Force due to gravity means that same value of G, right? And this force is less when she is on Earth's surface. Compared with being on Earth's surface, how do her mass and her weight change when she goes into orbit? So basically, they are talking about that the force of gravity is less on uh, the aircraft or the spacecraft where astronaut is orbiting, right? So the value of G uh, at a spacecraft, so we can write it as the value of G at a spacecraft is less than the value of G on Earth's surface, right? That is the meaning of first two statement. And the second thing they are talking about, compared with being on Earth's surface, how do her mass and her weight change when she goes into the orbit? So is there any difference in mass? First of all, they are talking about mass in orbit. So mass remains same or there will be any change in mass? आप
There will any change in mass, I
अ,
think.
आपके पास मास में कोई चेंज आएगा? जो हमने ये डिफरेंस लिखा था यहाँ पर, तो उसके अकॉर्डिंगली मास रिमेन्स सेम एवरीवेयर हमने लिखा. So it means
Yes.
that it will
Mass
remain the
remains same.
same. Yes. So it means mass remains same. So mass will unchanged. So there are 50-50 situation now, because we know that mass will never decrease, right? And if we talk about the weight, so when we are moving from Earth to the spacecraft, so our weight will increase or decrease?
It will increase.
It will increase. But according to
Yeah.
the question, they mentioned that the value of G is less than when she is on Earth's surface, decrease. So it means that the gravitational pull of the spacecraft is less than the gravity of the Earth's surface, right? So it means that while we are moving from Earth to the spacecraft, the weight will decrease, but mass remains same. So option C, right? Any confusion?
No, sir.
Okay. So basically, this is a concept between mass and weight. So you always need to remember the basic definition and the basic concept between mass and weight, the formula, the SI unit. These three things are very much important for mass and weight. All questions, we also solve some more questions, but the thing is that all questions are related to the same concept in your exam, right?